Okay, we're going over 22 on the homework here. If you didn't do it, let's get it open and get it done now with me. All right, it shouldn't be left blank after I get done with this. So we have AB, and it's going to be dilated by a scale factor of 2. We'll stop right there. Scale factor of 2. That means A and B are going to get closer or further away? Further away from 3, 5. All right, this is not an origin one. 3, 5 is not on here anywhere. All right, it's a different point. So we got to talk about how do I do this? Because I didn't talk about this yesterday. How do I dilate around just a random point? So first I want to get, it's already got there. A is -3, 4. B is 5, 2. And I'm going to dilate. Let's get that point graph too. 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. So here's 3, 5, my yellow point right there. So A and B are going to get further away. They're a certain distance right now. So A's got a certain distance away. It's going to double its distance. And it's going to double its distance on the same side. I'm not going to flip over on the opposite side of the point. So I'm going to use slopes to do this. I'm going to see from 3, 5 over to A, I go 1, 2, 3, 4, 5, 6, down 1. Do it again, right? Double that. Over 6, down 1. 1, 2, 3, 4, 5, 6, down 1. There's A prime. All right, there's A prime, and I'll do the same thing now for point B. Let's see, I go over and down. So I go over 2, down 1, 2, 3. Over 2, down 1, 2, 3. There's B prime. And it looks like I'm at choice 4, right? Does everyone understand why I just didn't multiply my A and B coordinates by 2? I'm only allowed to do that if it's centered at the origin. If it's centered at a random point like this one, all right, I got to use a little bit of slopes. Okay, use slopes. Great question. Way to go. Because I didn't cover this yesterday. All right, we all good? We're going to move on, or you got something else here for me? And just don't go through the problems right now. Oh, that looked tough, so let me ask them if you never tried it. We're all good? Okay, everybody needs their formula sheet out because we're going to fill in a couple blanks that may not be filled in already. And obviously day 4 of your packet. So let's get that out. You guys watch it 7th and 8th period, same thing. Formula sheets out. Day 4 out, calculators out. You should have. I'm going to give everyone plenty of time today to start some Regents questions. All right. Another common topic on the Regents exam: arc length and area of a sector. Both are formulas. They are formulas we need to know. We can't go in there just relying on our formula sheet. They won't be on there. So let's go first to your formula sheet and take a look at number 12. Okay, everyone take a look at number 12, arc length. There's 2 types. One, if the angle's in degrees, and you guys remember we just don't measure in degrees. It could be in radians as well. So the first one on there is the length of an arc if the central angle is in degrees. All right, so length of an arc if it's in degrees. And just a reminder, here you go. Measure of the arc over 360 times pi d. Pi d, another name for circumference. So that's how you find the length of an arc if your angle's in degrees. If it's in radians, which is your second part of that formula right now, if it's in radians, I called this one SOR. I don't know if anybody remembers that. SOR. S equals theta r. And let's go over each piece right now. S is the arc length. That's arc length. Theta That's my angle, but it's in radians already. So that's what I plug. I plug the radians in for theta. And do I have to label R? Are we good? Radius length. Okay, radius length for R. All right, we're ready to go. I'll get into sector in a minute when we get to it, but these first two questions deal with arc length. So let's take a look at number one. Angle B intercepts an arc. There it is, with a length of 2 pi. So that's how I know, hey, this is an arc length problem. What is angle B? Now, what do I need it in? Radians. So I don't want the degrees formula. I want the radians formula. All right, I want to make sure, because if I have to use this formula here, measure over 360 times pi d, that's going to give me the angle in degrees. Not interested. I want it in radians. So I'm going to be using S equals theta times radius. Arc length is already given. That's 2 pi. Where's that going to go in for? Theta? What's the 2 pi represent? Arc length, right? And what variable represents arc length in this formula? We just wrote it down. The S. So 2 pi is going to go in for S. That's the arc length. Equals, theta is my angle. That's what I'm looking for, right? If you want to put a B in there, if you want to put an X, if you want to leave theta, I don't care, just as long as we don't plug in for it. All right, you want to put B in there? Sure, let's put a B for angle B. And my radius is 10. Very easy problem if I know the formula and understand it. And then how am I going to get the 10 out of there? I'm trying to avoid the numbers today so I can go quicker. Divide both sides by 10. So in radians, angle B equals 2 pi over 10. Yeah, you know what? It's just not going to serve it up to you. It's there somewhere, but you guys have to understand, 2 pi over 10 can be done. Still can be done. How? I can still keep going. It's not up there. You're right. The answer's not up there. 2 pi over 10 is not up there. That's because 2 pi over 10 can still be reduced, simplified, correct, into pi over 5. All right, 2 over 10, reduce it down to 1 over 5. Any questions there? Arc length. All right, next one, Big Dom. All right, he's got 2 circles. Here's what Dom's saying. Angle A and B have the same radian measure. They have the same radian measure. We have to figure out if he's correct or not. And again, they are giving us, if you read through the problem, they're giving us arc length. So arc length, are they the same radian measure? I need S equals theta R. All right, help me out with circle 1 now. Circle number 1. What are you plugging in for? Where's the pi going? Circle 1, that's the S, arc length. Pi equals, you want to plug in A here for theta? A times 4. Everyone all right where I plugged all that in? Divide both sides by 4, just like we did in the previous problem. A equals pi over 4. If you want to take a look at that decimal in your calculator, you can. I just don't want to write it all out. All right, what about circle 2 now? Circle 2, a little bit more involved, but the same process. 13 pi over 8, there's my S. Equals B times 6.5. All right, yep, divide both sides by 6.5. Got to put this in a fraction template now. So get a fraction template, go to the numerator of that fraction template, and make a new fraction template. So you can put in 13 pi over 8 in the numerator and keep 6.5 in the denominator. and then compare that to the value of pi over 4. And hopefully you guys notice they're the same decimals, I hope. Because I believe Big Dom is correct. How they look, good? All right, there you go. I'm just going to keep it pi over 4. So Dominic is correct here. We okay using arc length? I know we didn't use the other formula, but if anything is in degrees, we use the other formula. If it's in radians, we use S equals theta r. Moving, anything? I'm moving. So you guys have enough time to practice. All right, get your formula sheet back out for me, please. And we are going to number 11. Area of a sector. Remember, a sector is formed by 2 radii, shaded region filled in. It's going to look pretty familiar from our degree formula for arc length. Instead, though, you're still going to do measure of arc over 360. But instead of multiplying it by the circumference, you multiply it by the area of a circle, pi r squared. And there's only one formula for that. I haven't seen a problem use radians at all for area of a sector. All right, here we go. Number 3. Go ahead and read it through. Area of the sector is 12 pi. What's angle AOC? What's angle AOC going to be? We're telling you the area is 12 pi in here, so I'm going to plug that in for area. Everyone all right? Why I'm plugging this in on the left side? Because that is the area of the sector. It's equal to, now we go back to the formula, measure of the arc. That's what we're trying to find, right? Angle AOC is the same as arc AC. I'm going to put an X there. That's what we're trying to solve for. Over 360 times pi 6 squared. Get rid of this now so we can solve. All right, now it's your algebraic skills. I'll start off. I see pi's on both sides. I know they're going to cancel. See ya. See ya. Keep the same colors. 12 equals x over 360 times 36. I don't know. What are you going to do from here? The geometry's over. We can multiply by 360 or divide by 36. Your call. All right, you're going to have to do either one eventually. All right, your call. So go ahead, finish it off. You can multiply both sides by 360 or divide by 36. Make sure you do the other one last. Whew. Area of a sector. Know your formulas. Quizlet. Index cards. However you roll. There's something else I'm missing. Kahoot? Okay, Kahoot it is. What do you have? Never heard of that one. $1.20. 120 degrees. Boom. All right, next up. Let's go over to this circle. That's 20 degrees. Ooh, the arcs are congruent, so we can put little congruent marks on the arcs, AC and BD. Find the area of sector BOD. So we're looking, just so we are clear, what's the area of this sector right here, BOD? Ding, 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 good. All right, so if I'm finding the area of the sector, I need to find something out of 360, right? Can you guys help me out finding what the heck is angle BOD? Because that's what I'm going to plug in above 360. How can I find angle BOD? The arcs are congruent. The one in the middle is 20. Hey, what do all three of those should add up to? 360. That's a whole circle. Those three arcs below, AC, CD, and DB, should add up to? Darn right they should. Add up to $180. I already know 20 is out, so now I'm down to 160, and the other two are congruent to each other. Use your magic. Each arc's going to be what then? 80? It's 160 divided by 2. Are we okay on how we know it's 80? You use 360. Get out of here. Now it's pretty easy, right? Times pi. R. 6 squared. And finally, directions. Leave your answer in terms of pi. So you right now, leave it in terms of pi. You better plop that pi in your answer right now. Go to your calculator and multiply everything else. Bless you. Devastated. I was looking for another one. I think you got one more in you this year. Maybe at the Regents. Eight pi. Looking good. Absolutely not. It's not. That's area of the circle. We're all good? We're going to fill that in right now, though. All right, so length of an arc, area of a sector. Final thing I'll do with you today, I'll talk about something else, but final thing we got to take notes on, circle equations. They ask every year. Go back to your formula sheet. We're filling out this bad boy big time today. Look at number 15 for me in your circle equation. Number 15. Circle equation. X minus h squared plus y minus k squared equals r squared. There's the equation of a circle. The two parts you need to remember, h and k, those will be numbers plugged in, and those numbers put together represent the center of the circle. Also, you'll have a number plugged in for r squared. The r, not r squared, just the r by itself represents, yes, radius length. All right, so there's two parts you need. You need the center to plug in, and you need the radius length. Okay, all good? Hopefully that's box number 15 on your formula sheet too. All right, let's go. All right, it will be on there, and I can almost guarantee you're going to have to complete the square to get. The Regents will not give you this. It's going to give you 5, where we're going to need to complete the square. So this is why we're reviewing it right now. Let's put some big time money on it. You're going to have to complete the square to get it into that form. So let's do it. Is equivalent to, first step, completing the square. Get your x's and y's grouped together. Rewrite it for me. Get your x's and y's grouped together. Single number, boot it over to the other side, please. So let's organize this so the x's are put together, y's are put together on the same side, and on the other side, I got my single number, aka 3 on the other side. So x squared minus 2x is together, plus y squared plus 6y is together, and then I move that 3 over, and it becomes negative 3. Next step, and I'm going to go through this a little quick because we have done it. Now you find the c value for x and y. You have a new c value for x and y. So x squared minus 2x plus this new c value, which we're going to talk about. How do I find it? Plus y squared plus 6y plus this new c value equals negative 3. Oh, anybody, come on, drop a little knowledge on me. How do I find that c value, magic c value again? X Games? Isn't that skateboarding?
You square it, right?
Square what?
The -2.
Not yet.
Not yet.
That's part of it. Could somebody help the poor kid out?
Is it half?
Oh, now we put two together. Maybe you guys could get a 90 together on the Regents, huh? Maybe. All right. Yes, I'm going to take my b value, half of it, and square it. So everyone in your mind right now, take half of -2. Okay, I got it. Square it. There's your new c value. Same thing on the y's. 6, take half of it, square it. 9. But please remember, it's unbalanced now. You have made this equation unbalanced. So over on the right side with -3, you also have to add in those c values. Next step, factor. Now it's going to start looking like our circle equation. So let's start with the x's over here. And again, two numbers that multiply to 1 but add to -2. They should be the same numbers. Multiply to 1, there's only one combination. And how do I make them to add to -2? X minus 1 and x. They got to multiply to 1. They got to multiply to 1. X minus 1 and x minus 1, also known as x minus 1 squared. And again, take half the b value. I don't have to worry about factor. Just take half the b value, and that's what gets plugged in. Over here, what was half our b value over here? 3, right? So y plus 3 all squared, and then make sure you combine everything over here. 10 and -3, 7. So we're looking at choice, be careful. Choice 2. Hey, I've been warning all my classes, the people who make up these exams are nasty. They want you to fall in any trap possible. Look at choice number 1. You forgot to add it to the right side, which is common. And you're going to select that one. All right. First, anyway, why would we ever select this? Can the radius ever be negative? Okay, so there's another, no way would I choose 1, but they want you to fall in any trap possible. All right, 6. 6 is going to take us less time because do you see there's nothing with the x? That means that coordinate's 0. So I don't even bother completing the square if there's nothing with it. All right, we're only going to complete the square on the y. Plus something equals 7. Don't even bother completing the square with the x's. We know that coordinate's going to be 0, as you can see from your multiple choices. All right, what's your new c value now? Half your b value squared, 9. Add it to the other side. So we end up with x squared plus, go ahead and factor, or just take half your b value. So it'll be y plus 3 equals 16. Now we got to take an extra step. What's the center and what's the radius? All right, let's talk center. We know it's 0, comma. What number must I have plugged in to get a plus 3? And remember, it's y minus k squared, right? So what number must I have plugged in for k to get a positive 3? -3, right? You always put in or take out the opposite. 0, -3. And what about my radius length, if that's a 16? Because remember, again, this is r squared, though. So it's not 16. The r value would be, if r squared is 16, r would be 4. You got to take the square root of it. And of course, look at the choices. They threw 16 on there. Pick me, pick me. All right, you ready for one more? We'll end it on a, I know there's a little bit extra, but I'll explain the extra. All right, 7. This is how hardcore it could get. Go ahead and read through. AB's a chord. The distance from the midpoint to the center is 2. What's the correct equation? All right, so first thing, we got to find the center. All right, we have to find the center. And we are told what? The center is located 2 units from the midpoint of AB. So it looks like we're going to have to find midpoint, right? We have not, you guys have not filled that in yet. I believe period 7 and 8 have. So let's fill midpoint in right now. I believe that's number 2 on your formula sheet. Midpoint formula. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. There's your midpoint formula. So using that formula, go ahead and find the midpoint of AB because the center is located 2 units from it. So go ahead and find the midpoint of AB for me. You know the coordinates, plug it into the formula now. Three, -2 look good? Plot it on the graph so we can talk. 3, -2. There's the midpoint. The center is located 2 units away. Whoa. Anybody see a question you may have? What question would you have here?
Which direction?
Thank you, which direction? Guess what? We got to do both. All right, I don't know which one's going to be the center. Is it the one to the left of AB or the one to the right of AB? I don't know, so we're going to have to do both versions right now. So everyone plot both possible centers right now. 1, 2. This could be the center, or 1, 2. This could be the center. So we're going to have to do this. We're going to have to create 2 equations that are correct and figure out which one is going to, in multiple choice answers. All right, everyone see that? It could be the one to the left or the one to the right. I don't know. All right, let's do the one to the left, which is 1, -2. So let's say our center might be 1, -2. What are we still missing though for the equation? What are we still missing? Think about the circle equation. I have the center. What's the other thing I'm missing, Anna? Radius length. All right, so how can I find radius length? See how points A and B, that was a chord? So those are on the circle, right? Those are on the circle. So how can I find the radius length? Take that center to the left right now, connect it to, let's say, A. That's a radius right there. Oh, I know you don't want to say it. So sorry, so sad. How are you going to find that length? Distance, yes, on a Friday. Let's go. Yes, can't get any better. You guys already have that written down, I believe. Yep. That's distance formula on a Friday. All right, so from 1, -2 to 3, 3, what is the distance? And we only have to do this once because it's going to be the same distance for the center on the right. Yes, I was hoping he did distance. So I got 1 - 3 squared plus, changing the y's now. Make sure you're using 1. I'm finding the distance from 1, -2 to 3, 3 right now. From the center to point A. Or you could also do to point B. We're going to get the same distance. And then -2 - 3 squared. God, who wants a little distance? Go ahead, calculate it. Calculate it. I don't want to do the work for you. Find it. 29. Oh, look. I get negative 2 squared, which is 4. And I get negative 5 squared, which is 25. 4 and 25 give you 29. Remember, after you square, those numbers should never be negative. Anytime you square any type of number, it's positive. Put it in parentheses in your calculator. All right, so what's the equation of this circle with this center, 1, negative 2? X, change the signs. So x, not 1, minus 1 squared plus y, change the sign, plus 2 squared equals, what's going to go on this side now? The radius length was radical 29, so what's r squared then? No. R squared. R is radical 29. That's the length of the radius. If I square it, just the number underneath the radical, 29. Quick check. Is that one of the choices? I believe it is. Choice 1. Now, if this was not any of the choices, guess what? I'd go over and use this point now as the center. No need to try out radius because it's going to be the same. All right, so if this was not a choice, I would then use the next point as the center instead, and that would be there. Questions? All right. The next part of this is volume and density, and I don't feel like we have to go over this because we just finished it last week. All right, so I'm going to leave those problems, and those problems also we've done in the last 2 weeks. They're in your volume density packet. All right, so do not feel the need to go over any of that stuff. The only thing you may want to do is it on here? Yep, number 9 on your formula sheet. We went over it last week. Density equals mass divided by volume. Okay, that's the only thing I would fill in your formula sheet. So you guys have plenty of time now. Same thing, 7th and 8th period. Get at your packets, your Regents packets, and try out those problems that are suggested below. All right, let's get going.